Alright, I went straight to chapter section 4.7 when it's talking about systems of linear equations. Oh, sorry, when it's talking about solving systems of equations using matrices. So this is, you might remember having some problems like this. And we solved them usually by the process of elimination. So for example, this y looks like it's pretty easy to isolate. So we might set up the equation and say 3x plus 3 equals y, and then we would substitute this into the next equation for y, and then we would solve for x. So that's all fine and good when you have nice numbers, but sometimes they're not so nice and things get a little bit more tricky. And that's when matrices become especially useful. So in this example, it's just going to show us how to rewrite this system of equations as a matrix. So it's showing you, you want to make sure it's in order. And by order, I mean make sure it's in x, y, z order if you have a third equation. In this case, it's just x, it's just x and y. And then you want the answer. So let me just put A for the answer. So we're going to look at the first one. They're all in the correct order. They've got the x first, then the y, an equal sign, and then the answer, or the constant as they're calling it. So let's rewrite that in matrix form. So you're going to open the matrix, and since we have two unknowns, this is probably going to be a 2 by 2 matrix. It's going to be 2 rows by 2 columns. So we'll go for the first one. That coefficient is 3, so we're going to write a 3 here. The next coefficient, you have to imagine what's there. So we have a negative sign and we have a 1y. So we're going to put -1. And then we're going to put a bar that stands in for the equal sign, and that equals -3. So our -3 is going to go out here. And then we're going to do the same thing for the next equation. So we've got a 2 for the x value, we've got a +3 for the y value, and that equals a +6. And then we can go ahead and end our bracket. So that's just called an augmented matrix. Augmented just means that it's kind of like two things put together. Sometimes you can have two matrices, such as like the matrix A and the matrix B, and you might augment that, but we'll get that into that much later. So let's go on to the next example. It's saying to please write each system of linear equations as an augmented matrix. So let's take the first one. We've got 5x minus 3y equals our constant, but then the other one's not in the correct order. So let's go ahead and rearrange this so that it is in the correct order. So we'll just move this, make this a -2x plus y equals -2. And now we can rewrite that. So we've got a 5 and a -3 and a -1. Are you with me so far? So here's our 5, here's our -3, and here's our -1. And then we'll go to the next row. We've got a -2 for our x value. You know, I'm going to put this as a c since they were calling that the constant. And then we've got a +1 here and a 2. And there's our 2 by 2 matrix augmented. And then let's go ahead and do the 3 by 3. So we'll take a quick check and make sure that it's in XYZ order. And it is. So now we can go ahead and write that. We've got a 6. I'm going to just write it down for simplicity for me. -5, 1, -3, 2, -4, 1, and then our constants are 3, 5, and -1. And this goes into greater detail if you feel like you need to follow along a little bit more. So here, we'll keep going, we'll do a couple more of these. So here we've got an xy, but here we don't. So let's rearrange it a little to make it into an xy equals a constant form. So that's going to give us 2x plus 5y equals -3. So we'll rewrite that 2 by 2 matrix as 3, 2, 8, 5, -3, -3. And then for part B, we've got, it's in proper order, so we'll just write down the coefficients. So we've got 2, 3, 1, -5, -1, 3, 3, 4, 2, 8, 7, and -3. So there's our augmented matrices for both of those. So go ahead and try this one if you haven't done it already. Give that one a try and see how it goes. And I'm going to stop this recording and then pick up with some others.